Hello there. In this video, we are going to focus on the second lesson that we learned from the financial markets, and that's the higher the risk, higher the potential return. And the keyword here is potential return because we never say higher the risk, higher the return, because you may invest in a very risky asset and you lose everything. So this is very important to qualify this statement to mention the potential returns. You're never guaranteed a return. If you take a high risk investment, you're never guaranteed high return. Sometimes you lose all your money. So the keyword here is potential. Higher the risk, higher the potential return. So let's get to it. We have already seen that year-to-year returns on common stocks tend to be more volatile than those of long-term government bonds. We now discuss measuring this variability so we can begin examining the subject of risk. Here you see a frequency distribution of returns on common stocks from 1926 to 2020. So over this 95-year period, obviously we have different amounts of returns. So what we're doing here in this graph, we're stacking the returns in different brackets. So for example, we count the number of years that our return was between -10 and -20. And there were 5 years that meet that criteria. And there were like 2 years that your returns was between 50% and 60%. So you do this, you stack these returns to form a frequency distribution for the annual returns of the stocks over this period. Here we're going to focus on risk, and risk is measured by dispersion, or how widespread these returns are. If they are centered around here, they're less risky. But if you have some returns here and some returns here and they're spread out, that asset is going to be riskier than those assets that the frequency distribution is centered around the mean. So we are going to measure the risk by calculating the variability or volatility of returns. What we need to do next is to measure the spread in returns. For example, we know that the return on large company stocks in a typical year is 12.2%. We now want to know how far the actual returns deviate from this average return in a typical year. In other words, we need to know how volatile the return is. And to do that, we're going to rely on variance and standard deviation. These are the most commonly used measures of volatility or risk in finance. Variance and the standard deviation, of course, measure the volatility of the asset returns, and the greater the volatility, the greater the uncertainty regarding the returns, and uncertainty usually is synonymous to the risk. And to calculate the historical variance, you sum the square deviation from the mean and then divide it by the number of observations minus 1. And the standard deviation is going to be the square root of the variance. So the bigger the variance and the standard deviations are, the more actual returns tend to differ from the mean. So here is normal distribution, and here is the mean. So the bigger standard deviation and variance, the more spread out the returns are going to be. The farther away from the mean your returns are going to be. Here's how we calculate the variance and the standard deviation. So you need to find the mean return, the average return, calculate the difference between your annual return from the mean, and then square that, and then divide it by the number of observations minus 1. And the standard deviation is going to be the square root of variance, equal sign here. So the standard deviation is the square root of variance. And here's how we calculate this. We have the annual returns from a couple of years before and after the Great Depression, from 1926 to 1930s. And we see that these are the annual rates of return. So the first step is to calculate the average return over this 5-year period, which is 11.88%. And then find the difference between the annual return and the average return for each year to get the difference. And then we square these differences, add them up to get the sum. And then we divide this sum by number of observations minus 1. So we have 5 observations. 5 minus 1 is 4. So this is your variance. And the standard deviation is going to be a square root of the variance. So 856.9 should be 29.27. So how do we do this in the financial calculator or in Excel? So let me show you this. Let's look at the financial calculator first. So to do this in the financial calculator, we need to use this data function. So you see on top of 7, we have data. So we do second 7. And in the data function, you can enter 2 series of data. So you have X's and Y's. Since we have 1 series of returns for 1 asset, we're going to just use X's here. So I have 11.6 for the first observation. And I don't have any Y's, so I'm just going to skip this. The second one is 37.49. Enter. 43.61. Enter. And 8.42 negative. And then finally, the last year is 24.9, also negative. So after you're done entering the the returns in, so after you're done entering the returns in the data function, you need to go to the stat function. So we go second 8, we're going to keep it as linear. N is the number of observations. X bar is the arithmetic mean of the observations. So you see this 11.88%. Then SX is the sample standard deviation, which is 29.27. So the calculator doesn't give you the variance. So if the question is asking for variance, you can just square this to get the variance, 856.90. And then sigma x is the population standard deviation. And I think that's all you need for now. And then in Excel, it's actually very easy. So we have the 5-year return here. The average is going to be your, let me just do it. Just delete these and then redo it. So we have average, and it's asking for the array of returns. The average is 11.88. Variance is going to be and standard deviation of the sample is going to be let me see if this is population, so I'm just going to change it to sample. So you need a standard deviation of the sample, stdev dot s, and also variance of var dot s. So we need the sample values here. Here is an example of the dispersion or variances for different asset classes. As you can see, the least variable one is US Treasury bills. These are the least risky asset class, and that's why the variance or standard deviation is smallest of all. And the most variable is small company stocks. Remember, small company stocks had the highest return of all compared to treasury bills, so it has the highest risk premium. But the standard deviation of this asset class, small company stocks, is almost 10 times the standard deviation of the standard deviation of the US Treasury bills. So the variance, the more spread out the returns, the higher the risk. The least spread out the returns, the safer the asset. I hope you find this video useful, and thanks for watching.